Thank you for returning with us for Subelement E5 Electrical Principles. 4 exam questions come from the 4 groups inside Subelement E5. E5A covers resonance and Q, characteristics of resonant circuits, series and parallel resonance, definitions and effects of Q, and half-power bandwidth. Question E5A01. What can cause the voltage across reactances in a series RLC circuit to be higher than the voltage applied to the entire circuit? Answer is A, resonance. E5A02, what is the resonant frequency of an RLC circuit if R is 22 ohms, L is 50 microhenries, and C is 40 picofarads? Answer is C, 3.56 megahertz. E5A03, what is the magnitude of the impedance of the series RLC circuit at resonance? D, approximately equal to circuit resistance. E5A04, what is the magnitude of the impedance of a parallel RLC circuit at resonance? A, approximately equal to circuit resistance. E5A05, what is the result of increasing the Q of an impedance matching circuit? Matching bandwidth is decreased. E5A06, what is the magnitude of the circulating current within the components of a parallel LC circuit at resonance? B, it is at maximum. E5A07, what is the magnitude of the current at the input of a parallel RLC circuit at resonance? A, minimum. E5A08, what is the phase relationship between the current through the voltage across a series resonant circuit at resonance? C, the voltage and current are in phase. E5A09, how is the Q of an RLC parallel resonant circuit calculated? Resistance is divided by the reactance of either the inductance or capacitance. E5A10, what is the resonant frequency of an RLC circuit if R is 33 ohms, L is 50 microhenries, and C is 10 picofarad? Answer is A, 7.12 megahertz. E5A11, what is the half bandwidth of a resonant circuit that has a resonant frequency of 7.1 megahertz and a Q of 150? Answer is C, 47.3 kilohertz. E5A12, what is the half power bandwidth of a resonant circuit that has a resonant frequency of 3.7 megahertz and a Q of 118? C, 31.4 kilohertz. E5A13, what is the effect of increasing Q in a series resonant circuit? C, internal voltages increase. E5B covers time constants and phase relationships, RL and RC, time constraints, phase angle in reactive circuits and components, admittance and substance. E5B01, what is the term for the time required for a capacitor in an RC circuit to be charged to 63.2% of the applied voltage or to discharge to 36.8% of its initial voltage? That's B, one time constant. E5B02, what letter is commonly used to represent substituents? D, the answer B. E5B03, what is impedance in polar form converted to an equivalent admittance? B, take the reciprocal of the magnitude and change the sign of the angle. E5B04, what is the time constant of a circuit having two 220 microfarad capacitors and two 1 mega ohm resistors all in parallel? Answer is D, 220 seconds. E5B05, what is the effect on the magnitude of pure reactance when it is converted to susceptance? D, it is replaced by its reciprocal. E5B06, what is susceptance? C, the imaginary part of admittance. E5B07, what is the phase angle between the voltage across and the current through a series RLC circuit if XC is 500 ohms, R is 1 kilo ohm, and XL is 250 ohms? The answer is C, 14.0 degrees with the voltage lagging the current. E5B08, what is the phase angle between the voltage across and current through a series RLC circuit if XC is 300 ohms, R is 100 ohms, and XL is 100 ohms? Answer is A, 63 degrees with the voltage lagging the current. E5B09, what is the relationship between the AC current through a capacitor and the voltage across a capacitor? D, current leads voltage by 90 degrees. E5B10, what is the relationship between AC current through an inductor and the voltage across an inductor? A, voltage leads current by 90 degrees. E5B11, what is the phase angle between the voltage across and the current through a series RLC circuit if XC is 25 ohms, R is 100 ohms, and XL is 75 ohms? It's B, 27 degrees with the voltage leading the current. E5B12, what is admittance? A, the inverse of impedance. E5C, coordinate systems and phasors in electronics. Rectangular coordinates, polar coordinates, phasors. Logarithmic axes. E5C01, which of the following represents pure capacity reactance at 100 ohms in a rectangular notation? Answer is A, which is 0-J100, or 0 negative J100. E5C02, how are impedances described in polar coordinates? C, by magnitude and phase angles. E5C03, which of the following represents a pure inductive reactance in polar coordinates? C, a positive 90 degree phase angle. E5C04, what type of y-axis scale is most often used for graphs of circuit frequency response? D, logarithmic. E5C05, what kind of diagram is used to show the phase relationship between impedances at a given frequency? That's C, phasor diagram. E5C06, what does the impedance of 50 negative J25 ohms represent? B, 50 ohms resistance in series with 25 ohms capacitive reactance. E5C07, where is the impedance of a pure resistance plotted on rectangular coordinates? D, on the horizontal axis. E5C08, what coordinates system is often used to display the phase angle of a circuit containing resistance, inductive, and/or capacitive reactance? It's D, polar coordinates. E5C09, when using rectangular coordinates to graph the impedance of a circuit, what do the axes represent? A, the x-axis represents the resistive component and the y-axis represents the reactive component. E5C10, which point on figure E5-1 represents the impedance of a series circuit consisting of a 400 ohm resistor and a 38 picofarad capacitor at 14 megahertz? That answer is B, which is 0.4. Alright, E5C11, which point on figure E5-1 best represents the impedance of a series circuit consisting of a 300 ohm resistor and an 18 microhenry inductor at 3.505 megahertz? Answer is B, 0.3. E5C12, which point on figure E5-1 best represents the impedance of a series circuit consisting of a 300 ohm resistor and a 19 picofarad capacitor at 21.200 megahertz? Answer is A, 0.1. E5D covers RF effects in components and circuits, skin effect, real and reactive power, electrical length of conductors. E5D01, what is the result of conductor skin effect? A, resistance increases as the frequency increases because RF current flows closer to the surface. E5D02, why is it important to keep lead lengths short for components used in circuits for VHF and above? B, to minimize inductive reactance. E5D03, what is the phase relationship between current and voltage for reactive power? C, they are 90 degrees out of phase. E5D04, why are short connections used at microwave frequencies? That's B, to reduce phase shift along the connection. E5D05, what parasitic characteristic uses electrolytic capacitors to be unsuitable for use at RF? And that's C, inductance. E5D06, what parasitic character creates an inductor's self-resonance? D. Interturn capacitance. E5D07, what combines to create the self-resonance of a component? B. The component's nominal and parasitic reactance. E5D08, what is the primary cause of loss in film capacitors at RF? D. Skin effect. E5D09, what happens to reactive power in ideal inductors and capacitors? B. Energy is stored in magnetic or electric fields, but power is not dissipated. E5D10, as a conductor's diameter increases, what is the effect on its electrical length? D. It increases. E5D11, how much real power is consumed in a circuit consisting of a 100 ohm resistor in series with a 100 ohm inductive reactance drawing 1 ampere? B. 100 watts. E5D12, what is reactive power? That's D. Wattless non-productive power. And that concludes subelement E5. Thank you for joining us, and hopefully you'll join us as we continue on with subelement E6.